Illustrative math, geometry, unit 2, lesson 2 is called congruent parts, part 2. All right, our goals today are I can identify corresponding parts from a congruent statement. I can use rigid motions to figure out if figures are congruent, and I can write a congruent statement. So these are the same goals that we did in the last lesson. If you were with me on that one. So if I were to write triangle ABC is congruent to triangle PQR. Well, that means you have 3 pairs of congruent angles. So as I look here, it would be angle A is congruent to angle P. The order that you write these really matters. All right, angle B is congruent to angle Q, and angle C is congruent to angle R. All right, and then you also have 3 pairs of congruent sides. So I got AB right here is congruent to PQ. I have BC is congruent to QR. And then the last pair of congruent sides would be AC and PQ. Now, it kind of looks like arc PQR, but I'm just pointing that the P and the Q go together, okay? All right, so each pair of figures is congruent. Decide whether each congruent statement is true or false. So here's my congruent statement. So that would mean angle A pairs up with F. It would mean angle B pairs up with E, or I'm saying pairs up, but really corresponds to, and also is congruent, and then C and D. Okay, so I'm gonna take this thing and see if I can do some rigid motion here. There's my translate, and then let's see. Oh, I need to reflect, not rotate. So pardon my craziness here. I would have just reflected across ED, but my software won't let me. So here I can see A is paired with F. That's good. B is paired with E. So that's good. And then lastly, D is with C. Okay. So this one would be good. This one is a yes. So that, or I guess true is what it says. It says true or false. That's true. All right, here's the next one. This one's pretty easy because it's just a translation. There we go. So it says P would correspond to L. So where's my P right here? P is with B. So right away, I can tell by looking at this with the P and the L right here. And I look, M matches with B. So, there's multiple things that are wrong here. There might be one right, like the Z and the Y looks right, and the J and the X look right, but these two are flip-flops. So this would be a false. Go down here. This one, whoops. This one's going to need to maybe rotate and translate. So I'm going to translate bidirected line segment KQ, and then rotate centered at Q counterclockwise. This won't let me rotate it centered at Q, but I can at least get it lined up. And there we go. So now you can see J is supposed to correspond to Q. And you can tell right here the J, and I know it's hard because it got turned, but the J was here. J is congruent to S. So this order is wrong. It really should be J goes with S, and then K is with Q, and then L is with R. So that's what it should be. Okay, so this one is false. All right, this one, these are regular pentagons, so really Oh, wait, maybe it's not a regular pentagon, actually. When I take a look at it here, actually, they do look pretty much the same here. I wonder if I could turn it again. They look like they're pretty regular. Hard to tell exactly, but because nothing's marked, they didn't mark angles congruent or sides congruent. So if I want A to correspond to P, I'm going to line A and P up just like I have right there. So A and P are good. Look at B and Q. B and Q are good. R and C are good. S and D and T and E. So this one is a true. Okay, this one is a true. All right. All right, so here are three triangles. Triangle PQR is congruent to which triangle? Explain your reasoning. So what I need to do is I need to translate by directed line segment either PA or PM. I don't know which one it's going to be, but I can see that those are the same angle measure. So I need to get P aligned with either A or M. All right, and I think this is the one that it's going to be. I think this one here, I don't think the other ones will match up. I don't think it'll work because, when I rotate this thing at P, PQ is not going to be the same length as AE. And same thing here, PR is also much longer than AE. So I don't think I'll ever be able to rotate to align a side. So when I get here, though, I could rotate this thing. Um, I could rotate this thing. Let's see here. Right here. Okay, counterclockwise, centered at M, and it will be able to align RP and LM. So let's do that. And then if I reflect over there, I can get Q to align with N. So my answer here for this one here, so which triangle is it congruent to? So I have to put it in the same order as PQR. So P is with M, R is with, I can't tell what letter R is on top of, or I'm sorry, Q goes with N. So Q will align with N, and then the R is aligned with L. That was it. Okay, so there's that. Show a sequence of rigid transformations that takes PQR to that triangle. Draw each step. So translate PQR by directed line segment PM, which was what I did. And then rotate P prime, Q prime, R prime counterclockwise until LM and P prime, R prime align. I guess I should have the word align in here. Reflect P prime, Q prime, R prime, or P double prime, Q double prime, R double prime across LM. And there they are. So why can't rigid motions work on the other one? When we translate triangle PQR by directed line segment PA to align P and angle A, angle P and angle A, we cannot rotate triangle P prime, Q prime, R prime in a way that aligns the sides. So, kind of like I had over here. I'll take it back to where we were. When I come here and I align this P and A and I start trying to rotate this, like you can tell here, centered at P, this PQ is never going to match up. And even the other side, the PR, if I keep it centered at A, you see how we're just way too long. You'll never be able to get a side to line up. All right. Next thing, triangle ABD, and I traced it already to make it a little easier, is a rotation of triangle CBD around point E by 180 degrees. Is angle ADB congruent to angle CDB? So I'm going to mark these angles here. Angle ADB, is it congruent to CDB? That's what I want to know. All right. Are those congruent? So if so, explain your reason. If not, which angle is it congruent to? So this angle here, here's what I want you to do. Look at this angle right here, angle D. When I rotate this thing, and this one's nice because it actually does it right at the center. That angle, it's just slightly off. That angle goes up here. Okay, this is angle D right up here. So these two are actually the congruent ones. All right, and then this angle came from over here. Okay, so I'll mark this one here with 2 marks. So you can tell that it's congruent to so ADB. So ADB right here is congruent to CBD. Okay, CBD. Get rid of that. All right, over here, polygon HIJKL is a reflection and translation of polygon GFONM. Is segment KJ congruent to NM? If so, explain your reasoning. So KJ and NM. So KJ, whoops, hold on, that was not going to work. So KJ, if you look where they're at in the statement here, they're the third and fourth letters, and NM are the fourth and fifth letter. So I don't even need to look at it to know that they're not going to match up. They're not going to be congruent. Here's NM. KJ is right here. You can also see that KJ, you can just kind of tell by the, if I translate here, ON is gonna correspond to JK, so those will be congruent. NM is gonna correspond to KL, and you can kind of tell in the statement here, NM are the last two, KL are the last two. JK are the third and fourth letters, so ON are the ones that are going to go with it. So this one here, I would say no. I would say angle. I'm sorry, not. It'd be segment. Let's see here. N. Which segment? The answer is no. And then you would say segment NM is congruent to segment KL. Okay. Quadrilateral PQRS is a rotation of polygon VZYW. Is angle QRS congruent to ZYW? If so, explain your reasoning. If not, which angle is QRS congruent to? So when I look here at this, it's really important to look at the order of the letters. So QRS and ZYW, see how they're in the exact same spot? They are congruent. So this one would be a yes. Angle QRS is congruent to angle ZYW. Excuse me. So my reasoning would be that the congruency statement, they're in the same order in the congruency statement. Excuse me. All right. So here's another one. Is this congruent statement written correctly? If not, rewrite it correctly. So A corresponds to J, B to K, C to L, and D to M. So let's see if this works. So I'm going to get that A to line up, and then I'm going to rotate it. And there we go. So A is with L. B goes with M. So it's gonna be different here. So this is gonna be A, B, C, D is congruent to, what did I say it was? It was L, M, J, K. If I follow around this order, A and L, M and B, C and J, and D and K. So it's L, M, J, K. All right, so back to our goals. I can identify corresponding parts from a congruent statement. I can use rigid transformations to explain why figures are congruent. I can write a congruent statement. So write a congruent statement for each pair of congruent figures, okay? So this thing's got to get turned, and it looks pretty good right there. So let's just start here with O, P, L, M, N. You have to go in order. So if I start at O, I got to go O, P, L, M, N, or O, N, M, L, P. It doesn't matter which way you go, but and it also doesn't matter what letter you start with. But then they all have to match up. So I went O, P. So I'm going to go Y, A, and I'm going to go around that way. So it's going to be is congruent to Y, A, H, F, S. And then I come over here, this thing needs rotated. So there it is. So I'll just stay in order. I'll go C, D, E, F. So the C was with W, the D was with X, the E was with U, and the F was with V. So I'm going to go this way. It's going to be W, X, U, V. So O, N, M. Put the triangle symbol there. O, N, M is congruent to right there. O is with U, N is with E, and M is with T. So U, E, T, triangle. Okay. And that's it for this video. Hope you enjoyed it. Thanks for watching, and we'll see you next time.